Hi guys, welcome to Science in 5, where math and science can be explained in 5 minutes. In this video, we're going to talk about the relationship between frequency and wavelength of a wave. The speed of a wave is equal to the product of the wavelength and the frequency, which can be represented by the equation C is equal to lambda f. This equation C equals lambda f has an alternative form V equals lambda f. But whenever we talk of electromagnetic radiation, we tend to use the first form, which is the C equals lambda f, where the C represents the constant speed of electromagnetic radiation, commonly referred to as the speed of light, 3 times 10 to the power 8 meters per second. Suppose we are given 3 wave patterns: a red pattern, a green pattern, and a purple pattern. What are the differences that can be observed? Well, it looks like the red patterns, there are few of the waves. The green pattern, there are more of the waves. The purple pattern, there are a lot more of the waves than the other two. Correct observation. We can also see that the wavelength of these wave patterns is different. The purple has got the smallest wavelength, followed by the green, and the red has the largest wavelength of all 3 patterns. But we notice that the red has the fewest waves that are seen in this pattern, and the purple has the most number of waves. So is there a relationship between the wavelength and the frequency? And what is that relationship? It appears as the wavelength decreases, the frequency increases. Okay, let's try and prove this with a calculation. Suppose we are given the wavelength of all 3 waves. The red, the lambda is equal to 2 meters. The green, the lambda is equal to 2 millimeters. And the purple one, the lambda is equal to 5 micrometers. Using the equation C equals lambda f, and assuming that these wave patterns are for electromagnetic radiation, we can easily calculate the frequency of each of the waves. For the red pattern, C equals lambda f, we know that the wavelength is 2, so it's an issue of plug and play into the formula. We get the frequency is 1,5 times 10 to the power 8 hertz. For the green wave pattern, the wavelength is 2 millimeters. It's now actually smaller than the red pattern. Will the frequency be larger or smaller? The frequency is actually greater. For the purple pattern, the wavelength is even smaller, 5 times 10 to the negative 6 meters or 5 micrometers. Will the frequency be larger or smaller? So the frequency is actually the largest of the 3 wave patterns. So as the wavelength decreases, the frequency increases. So this is a relationship that we need to be aware of whenever we deal with wave patterns. As the wavelength of electromagnetic wave decreases, their frequency increases. As the wavelength of the electromagnetic waves increases, the frequency decreases. We can term this kind of relation an inverse relationship. Okay? Frequency is inversely proportional to the wavelength if the speed is constant. Wavelength is inversely proportional to the frequency if the speed is constant. This can be represented by these 2 graphs. Looking at the first graph on the left, well, if we start off with a frequency value there, it will correspond to a certain frequency value. We increase the wavelength value, the frequency value decreases. This can also be represented in this formula, C equals lambda f. The C is constant. If the lambda increases, the F decreases. And if the lambda decreases, the F increases. That's an inverse relationship. Thank you guys for watching. Don't forget to subscribe or like or comment. See you next time.